Hi! In this lesson, we will talk about the very first steps a good data scientist takes when he's given a new dataset, namely exploratory data analysis, or EDA in short. By the end of this lesson, you will know what are the most important things from data understanding and exploration perspective we need to pay attention to. This knowledge is required to build good models and achieve high places on the leaderboard. We will first discuss what exploratory data analysis is and why we need it. We will then go through important parts of EDA process and see examples of what we can discover during EDA. Next, we will take a look at the tools we have to perform exploration, what plots to draw, and what functions from pandas and matplotlib libraries can be useful for us. We will also briefly discuss a very basic dataset cleaning process that is convenient to perform while exploring the data. And finally, we'll go through exploration process for the Springleaf competition hosted on Kaggle some time ago. In this video, we will start talking about exploratory data analysis. So, what is exploratory data analysis? It's basically a process of looking into the data, understanding it, and getting comfortable with it. Getting comfortable with a task probably always the first thing you do. To solve a problem, you need to understand the problem and to know what you are given to solve it. In data science, complete data understanding is required to generate powerful features and to build accurate models. In fact, while you explore the data, you build an intuition about it. And when the data is intuitive for you, you can generate hypotheses about possible new features and eventually find some insights in the data, which in turn can lead to a better score. We will see the examples of what EDA can give us later in this lesson. Well, one may argue that there is another way to go. Read the data from the hard drive, never look at it, and fit a classifier immediately. Then use some pretty advanced modeling techniques like mixing, stacking, and eventually get a pretty good score on the leaderboard. Although this approach sometimes works, it cannot take you to the very top positions and let you win. Top solutions always use advanced and aggressive modeling, but usually they have something more than that. They incorporated insights from the data, and to find those insights, they did a careful EDA. Well, we need to admit there are competitions where all you can do is modeling and EDA will not help you to build a better model. It is usually the case when the data is anonymized, encrypted, pre-processed, and obfuscated. But look, you will anyway need to perform EDA to realize that this is the case, and you'd better spend more time on modeling and make your server busy for a month. One of the main EDA tools is visualization. When we visualize the data, we immediately see the patterns, and with us ask ourselves, what are those patterns? Why do we see them? And finally, how do we use those patterns to build a better model? It also can be another way around. Maybe we come up with a particular hypothesis about the data. What do? We test it by making a visualization. In one of the next videos, we will talk about the main visualization tools we can use for exploration. Just as a motivation example, I want to tell you about a competition Alexander Dyakonov, a former top 1 at Kaggle, took part some time ago. The interesting thing about this competition is that you do not need to do any modeling if you understood your data well. In that competition, the objective was to predict whether a person will use the promo that a company offers him. So each row corresponds to a particular promo received by a person. There are features that describe the person, for example, his age, sex, is he married or not, and so on. And there are features that describe the promo. The target is 0 or 1. Will he use the promo or not? But among all the features, there were two especially interesting. The first one is the number of promos sent by the person before. And the second is the number of promos the person had used before. So let's take a particular user, say with index 13, and sort the rows by number of promos sent column. And now let's take a look at the difference at column the number of used promos between two consecutive rows. It is written here in div column. And look, the values in div column in most cases equal to target values. And in fact, there is no magic, just think about the meaning of the columns. For example, for the second row, we see that the person used one promo already. but he was sent only one before that time. And that is why we know that he used the first promo, and thus we have an answer for the first row. In general, if before the current promo the person used n promos, and before the next promo he used that, we know that he used n plus 1 promos, then we realize that he used the current promo. And so the answer is 1. If we know that he used n promos before the next promo, exactly as before the current promo, then obviously he did not use the current promo, and the answer is 0. Well, it is not clear what to do with the last row for every user, or when we have missing rows, but you see the point. We didn't even run a classifier and we have 80% accuracy already. This would not be possible if we didn't do an EDA and didn't look into the data. Also, as a remark, I should say that the presented method works because of a mistake made by the organizers during data preparation. These mistakes are called leaks, and in competitions we are usually allowed to exploit them. We will see more leaks examples later in this course. So, in this video we've discussed the main reasons for performing an EDA. That is, to get comfortable with the data and to find insights and magic features. We've also saw an example where EDA and the data understanding was important to get a better score. And finally, the point to take away. When you start a competition, you'd better start with EDA and not with hardcore modeling. We have a lot of things to talk about in this lesson, so let's move to the next video.